Hello everyone, like I promise you guys, I will always update you after each and every class. For sure, I won't explain the same way like I explained in class, like on online with me on my videos. I won't explain the same way. The reason is just because of time, and the other reason is because of the software. I mean, like sometimes uploading heavy videos is the problem. So I'm going to talk about electronics one. I'm going to talk about electronics one. Today we had a class. The classes was around 10, but few students show up. Some they give me a reason they were busy, were on campus. Some they're still fixing the story about the registration and everything, but no problem. I'm gonna try to summarize everything what we discussed about today. We talk about chapter 0 that I was saying, electrical circuits. We spoke about electrical circuits. That was, I say, it was our chapter 0, which is not part of that electronics device book. So we spoke about three type of resistors, circuits. We spoke about series circuit, the three type of circuit, which is a series circuit. We have a resistor R1, let's call it resistor R2. We have our total voltage, and we spoke about parallel resistor also, parallel circuit, R1, R2, and everything connected to the voltage, total voltage. And the last one, we have our V total. The last one is the combine of these two series and parallel circuit. We have one, and we have another resistor that go back to the negative side of the source. We have our positive, we have our negative. Let's call it resistor R4, let's call it resistor R1, let's call it resistor R2 and resistor R3. So guys, we spoke about these three type of resistors. I said the first one is a series circuit. Is a series circuit. This one is a parallel circuit. This one is a series and parallel circuit, the last one. Like I said, guys, why do we call it a series circuit? I'm going to try to explain in the simple way because it's online, to avoid the why and how, maybe, yeah. So the current, why we say this one is in series, because when the voltage, when the source of power supply, the source will will produce current or will transmit or conduct current. The current will flow from positive to negative, so in this direction. So it's flowing from positive to negative, so it's go back to the source. So along the way, when the circuit was passing through the whole circuit, the current didn't change any direction, didn't split into part. The same amount that flows here, it's like it's a one-way, like a type of one-way, positive to negative. So the current didn't change any direction or didn't split. The current just travel all the way from positive to negative. Nothing stopped the current, nothing split the current. So in this case, we say that this is a type of series circuit, because the current total is the same across resistor R1 is the same across current across R2. So in case, let's say if you have 9, if this is 9 ampere, so here the current here gonna be 9 ampere, the current also here will be 9 ampere in series circuit. So in series circuit, the current is different across, the current is the same across each and every resistor connected in series straight to the voltage. So the other thing, it was this on parallel side. On parallel side, guys, check the difference. The current will flow from the positive side of the power supply of the source, and then when it's gonna arrive here by the node here, we have two branches, right? The current won't just choose to give current to R2. I need to share the current with these two resistors, so it's gonna give some here on R2 and it's gonna give some here on R1, and the same current will come here, meet each other here by the corner here. The same current will meet each other there and go back to the source. So that's why we say this one is the parallel circuit, because the current, when it's flowed through the circuit, when it's gonna reach the node, the current will split in two parts, share some amount of current for R1 and R2, and goes back to the source. So in this case now, current total of parallel circuit, it's equal to the sum of current of resistor R1 plus resistor R2. That's why we say this circuit is a parallel circuit, because the current is not the same across each and every resistor, because it's gonna split, it's gonna change direction, it's gonna split in two parts. Some of the current is gonna share that current between R1 and R2. So let's check now in series and parallel circuit. Check here, guys, if the current flow from the positive side of the power of the voltage or the power supply here of the source, the current will pass through R1, and then if the current was 9 ampere across R1, here we're going to have 9 ampere. The current through R1 is going to be 9 ampere, but when it's going to arrive this side, it's going to split in two different parts. So it's going to give some in R2 that will be different with R. That's going to be different. That current will be different to 9. So the current on R2, it's going to be different. Same thing here. It's going to be different. 9 ampere will be different from current that will flow from R1. So here we have a parallel. But when it's going to arrive again to this node, the same current, this same current and this same current, they're going to combine. So we're going to have our R2 plus R3, so here it's 3, not 1, 3, and then here it's gonna flow, go back to the source. So here on R4 we're going to have 9 ampere. So this is what we call a parallel circuit. So series and parallel circuit. So let's go back to our series circuit. In the series circuit, we say again the voltage across, the voltage total in series circuits, it's the sum of voltage resistor R1 plus resistor R2. Why? The question is like, why? Because the voltage doesn't flow from a positive source of the source to the negative like a current. The voltage will supply. I'm going to explain in the simple way for you to understand, like in the very basics method. The voltage here, it's connected directly, is holding one end of this resistor, and this other positive is holding one end of this resistor. So it's going to share them the voltage. It's going to share them the voltage in other. So the voltage total here is the sum of this resistor, the voltage across R1 and R2. So that's why we say R1 and R2. That's adding R1 and R2. That is the voltage across. That's the total voltage, the amount of total voltage. If it was 3 of them, it's gonna be the voltage of each and every resistor across here. So we discussed also how we calculate the total resistors in series circuit. The total resistor in series circuit, we just add all the resistors that are connected in series straight to that voltage. So we're going to add R1 plus R2. This is how we calculate the total resistor in series circuit. So let's come now in parallel circuit. In parallel circuit, the voltage total is going to be the sum is going to be different. It's going to be the same with voltage across R1, which is going to be the same across voltage across R2. Look at this case, check in this case. In this case, the voltage is holding these two hands, these two branches, branch of R1 and branch of R2. So here also is holding the voltage of these two branches. Different in this case where the voltage is holding only one side of the resistor and the other side of the resistor. Here it's holding the two branches. That's why we say voltage total is equal to VR1 plus VRA equal to VR2. So if the voltage total here is, for example, 12 volt, everything will be equal here to 12 volt. So this is what we discussed. And then something I said to calculate the total resistor in parallel circuit. If you deal only with two resistors, it's going to be R1 times R2. Like in this case, we have only two resistors over R1 plus R2. But if you deal with more than one resistor, so we can write it like 1 over R total, which is going to be 1 over resistor R1 plus 1 over resistor R2 plus dot 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 number of resistors that you're going to have. So this, if you want to make RT total subject of the formula, so you can say everything, so 1 over R1 plus 1 over R2 plus dot 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 1 over Rn, and then everything. Or in another way also, you can say R total is going to be equal to 1 over R1 or 1 over R2 plus dot 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 1 over Rn, and everything minus 1. So this is how we calculate the total resistor in parallel circuit. So in the next video, I'm going to explain different method, because we're going to talk about different method how to solve question about electrical circuit. Which type of question that you're gonna come across for this video, I'll stop here. I don't want to make very long videos. I want to make short videos so that can push you to go through and study also. Thank you for watching the video. I'm gonna upload the other video in few hours. Yes, thank you.